Okay, so now we're going to learn about some special ratios where in a right triangle we're going to compare different sides of the right triangle. So comparing the opposite and adjacent, the adjacent and hypotenuse, the opposite and the hypotenuse. So it's these different ratios, and depending on the measures of the angles and the measures of the sides, these ratios will be different. So sine, which is a really weird word, sine is the ratio of the length of the opposite side to the hypotenuse. So you're going to put the opposite side in the numerator and the hypotenuse in the denominator. And so what you're doing is you're finding sine of theta. So you're finding sine of the angle. So this value that's going to go inside the parentheses, that's your angle. So sine of your angle is going to give you a ratio that's comparing the two sides, opposite over hypotenuse. The length of the opposite side, which is a number, over the length of the hypotenuse, which is a number. So this will give you a ratio. So this number, opposite over hypotenuse, is going to be like a fraction or a decimal. So it's going to be like some value that's like in between. It's going to be like greater than 0 but less than 1. So you actually need to write that. It's going to be bigger than 0 and less than 1. Cosine is the ratio of the length of the adjacent side to the hypotenuse. So it's adjacent over hypotenuse. So you're going to put theta in the parentheses, your angle in the parentheses, and then adjacent over hypotenuse. Adjacent over hypotenuse. Cosine of theta is adjacent over hypotenuse. And then tangent is the ratio of the length of the opposite side to the length of the adjacent side. So theta goes inside the parentheses, and it's the ratio of the length of the opposite side over the length of the adjacent side. So tangent can sometimes be, it can be bigger than 1 or less than 1. It just depends. So sine and cosine are always going to be less than 1. It is possible for tangent to be greater than 1. Okay, so you're probably thinking, Miss Briscoe, these words, sine, cosine, and theta, sine, cosine, and tangent are super weird, and then you're wanting me to remember which one's opposite and over hypotenuse, which one's adjacent over hypotenuse, which one's opposite over adjacent. Oh my gosh, I'm so overwhelmed. That's so many words and so many things to memorize. There is the best acronym in all of math. It's awesome, and it sounds crazy, but it's super helpful. And if you ask people, like, what do you remember from pre-cal? What do you remember from geometry? What do you remember from trig? They're like, oh, that's SOHCAHTOA. Like, some people just call this whole concept SOHCAHTOA. This acronym, S-O-H, SOHCAHTOA. SOHCAHTOA, SOHCAHTOA. I love SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. It's the golden ticket. So what SOHCAHTOA does is it helps us remember S for sine. S for sine. Sine is O for opposite, H for hypotenuse. So sine is opposite over hypotenuse. S-O-H. So sine is opposite over hypotenuse. Cosine, C-A-H. Cosine is adjacent over hypotenuse. C for cosine, A for adjacent, H for hypotenuse. Cosine is adjacent over hypotenuse. Tangent, T for tangent, is opposite over adjacent. SOHCAHTOA. Tangent is opposite over adjacent. So if you can remember SOHCAHTOA, SOHCAHTOA, say it with me. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. If you write SOHCAHTOA at the top of every paper that you do for Trig, and just go back and reference this, you're going to be golden. SOHCAHTOA, SOHCAHTOA, remember SOHCAHTOA, and it will help you so much. So what we're going to do is we're going to practice using SOHCAHTOA. We are going to actually find these ratios. So if you notice, this says sine of L, cosine of J, tangent of J. Remember the thing inside the parentheses. So you're finding sine of something. This is your angle. Sine of whatever goes right here is representing your angle. So on these problems, L and J are these angles. We're finding sine of certain angles. So notice we're going to find sine of angle L, and that's going to be something different than sine of angle J. So when I change the angle, I'm going to change the ratio. Okay, so let's do the first one. Sine of angle L. So here's angle L. Angle L is now my theta. Angle L is my theta. So I want to identify which side is opposite, which one's adjacent, and which one's hypotenuse. So my hypotenuse is always going to stay the same. My hypotenuse is 34. If my angle is L, which of the two legs is my opposite leg? Well, if my angle is L, 16 is all the way on the opposite side of the triangle. So 16 is going to be my opposite side, and 30 is going to be my adjacent side. So when my angle, when my theta is L, my opposite side is 16 and my adjacent side is 30. Okay, I'm going to put SOHCAHTOA at the top of my paper. SOHCAHTOA. So I want to find sine of an angle. So I'm going to go look at SOHCAHTOA. Sine starts with the letter S. Sine is O over H, opposite over hypotenuse. Opposite over hypotenuse. So my opposite side of angle L, the side that's opposite from angle L, is 16. And the side that's the hypotenuse is 34. So I have 16 over 34. So all I have to do now is just reduce it. I'm just going to type that in my calculator and press math enter, because that reduces fractions for me. And that gives me 8 over 17. 8 over 17. So it asks specifically for me to keep it as a simplified fraction. So that's my final answer, 8 over 17. Okay. While I'm already looking at angle L, let's go find cosine of angle L. Cosine, if I go look at SOHCAHTOA, cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. So when my angle is L, which side is adjacent to angle L? 30. So I'm going to go put 30 in place of adjacent. And again, my hypotenuse always stays the same. My hypotenuse is still 34. So that ratio, 30 over 34, reduces to 15 over 17. So notice sine and cosine for angle L are different in this triangle. Okay, then we want to find tangent of angle L. Tangent, if I go look up at SOHCAHTOA, tangent starts with a T. Tangent, T, is O over A, opposite over adjacent. So tangent of angle L is going to be the opposite over the adjacent. If my angle is L, my opposite side is 16, and my adjacent side is 30. So 16 over 30, I'm just going to reduce that as much as possible. Math enter. I get 8 over 15. Okay, so now for the remaining questions, now I've changed my angle. My angle is no longer angle L. I'm now finding sine of angle J, cosine of angle J, tangent of angle J. So now my theta is J. So that's going to change which side is the opposite side and which side is the adjacent side. So now that I'm considering angle J to be my theta, that means that 30 is now my opposite side because theta is all the way across from this side, and 16 is my adjacent side because it's just bloop right next to that angle. So now my adjacent and my opposite side have switched because I've changed which angle I'm considering to be theta. My hypotenuse stays the same though. Okay, so sine of angle J. Remember sine up here, S is for sine. Sine is opposite over hypotenuse. Opposite over hypotenuse. So which side is opposite of angle J? It's 30. And then my hypotenuse is 34. 30 over 34 reduces to 15 over 17. Okay, now we want to find cosine of angle J. Cosine is adjacent over hypotenuse, A over H. Which side is adjacent to angle J? Well, 16. And then my hypotenuse is 34. And 16 over 34, adjacent over hypotenuse, 16 over 34 reduces to 8 over 17. And then finally, tangent of angle J. Tangent, T for tangent. Tangent is opposite over adjacent. Opposite over adjacent. Oops. Tangent is 30 over 16. And that's going to reduce to 15 over 8. That's an 8. 15 over 8. So notice two things. When we change the angle, we're changing which side is the opposite side and which side is the adjacent side. Hypotenuse is always going to stay the same. Second thing, for sine and cosine, it's always it's like one of the legs over the hypotenuse. Remember, your legs always must be smaller than the hypotenuse. That's what it means for this side to be the hypotenuse. It's the longest side in the right triangle. So since for sine and cosine, my hypotenuse is always the biggest number, that means my denominator is always going to be bigger than the numerator. So these fractions should always be less than 1. So if you ever get your value of sine or cosine is bigger than 1, that's a problem. Because remember, your hypotenuse is always the biggest, and your hypotenuse always has to stay in the denominator.